What's poppin', dogs? Mr. Allen here with some ACT prep focused on logarithms in this video. I got a ton of different scenarios here, some evaluating, some solving, all sorts of good stuff. For this first one, I've got what is the value of log base 5 of 625? So in your brain, you're thinking 5 to what power gives me 625? And that might be kind of challenging. So why not just bust out your calculator for this one, hit math, then the alpha button above it, and then math again, and up pops this log any base. I can literally just type this in, 5 and then 625, hit enter, and I've got 4 for my answer here. It is choice B, easy peasy. However, I have seen this problem worded in a way with different answers. And what they do is they have things like this. They have which of the following is equivalent to, and they might write it as log base, or just log of 625 times log of 5. Well, that's not the right answer. But if you see the answer of log of 625 divided by log of 5, check this out. That is called change of base. And now if I just hit the regular old log button of 625, close my parentheses, do a little division, and I'll hit log of 5, close it, I get the same answer. They could also here, guys, do natural log. So even if they did natural log of 625 and natural log of 5, you would still get the exact same answer here. So be on the lookout for either of these two answers being the equivalent form. And the way you could check that, if you're like, bro, what? You could, once again, just type this in, natural log 5, close my parentheses, I got 4. Got 4s all day. Choice B is the answer. That's about it for this one. So why don't you guys try this next one on your own? It's a little more complicated, but the same concept. What is the value of the expression log base 6 of 36 times log base 3 of 9? See if you guys remember how to type it in your calculator right now, or even try it in your head. 6 to what power gives me 36? 3 to what power gives me 9? And multiply them. All right, now I'm going to type this thing in. We have math, alpha, math. I'm going to type 6, then 36. If you were doing this one in your head, 6 to the second power is 36. And then I'll hit math, alpha, math again. And then I've got 3 in the base this time, 9 over here. 3 to the second power equals 9. So it should be 2 times 2 is 4. Let's see if we got, oh my goodness. 4s all day, baby. We got choice C on this one. Excellent. So here's an interesting one. We have what is the value of x in the equation log base 3 of 54 minus log base 3 of 2 equals log base 2 of x. Okay, so we got different bases on each side here, which complicates things. But what we can actually do is I could condense the left-hand side down to log base 3 of 54 divided by 2. So subtraction condenses down to division once we put it into one logarithm. So I have log base 3 of 27. And if you're able to evaluate some logs by hand in your brain ski, 3 to what power gives me 27? This is just 3. So now I have the situation 3 equals log base 2 of x. Can we solve that? Yes, we can. It's like Bob the Builder or something like that. All right, we can rewrite this thing in exponential form by doing a little loop and a swoop, okay? So I'm going to take this 2, and I got to go backwards for this one. We start with our base. 2 raised to the third equals x. So I'm going to have 2 raised to the third power equals x, and that is going to give me 8 right here. Do we have that choice? Yes, it is choice G, which is good. Dope. Now, if you didn't know this this part over here, the log base 3 of 54, you actually could have done math, alpha, math. We got 3 for my base, 54, and then we have minus math, alpha, math, 3, and then 2, hit enter, yay, we get 3 over there, and now I have log base 2 of x equals 3. Hopefully you know how to rewrite that in exponential form. Definitely something you guys want to know how to do. Loop and swoop is my preferred method. You always start with the base, and then you end on the argument of the log. The same idea if I have exponential, I want to go to log, I start with the base 2, and I end on my exponent, so I'd have log base 2 of x equals 3, which is what we have right there. So the loop and the swoop works going in either direction. All right, that's dope. Next problem. All right, dogs, we got uno mas problema for this video. We're going to break it into 2 parts because there's just so many dope problems that can pop up with logarithms on the ACT. So stick around for part 2. But for now, let's get after it on this one. We got let A and B be positive real numbers such that log of A equals 3 and log of B equals 2. What is the value of log of the quantity A squared times b. Well, first thing, when there's no base written with the log, it's assumed to be the common logarithm, which is base 10. That might come up here. It might come up in another problem. Keep that in your brain there for later. So what do I do with this one? Well, did you know that you could rewrite this log of a squared times b as a sum of two logarithms? Multiplication expands to addition, whereas division, or a quotient, expands to subtraction, or a difference. So I could actually rewrite this as log of a squared plus log of b. Now, almost ready to rock and roll here, but if I also then bring that 2 out front as a coefficient, another property of logs, the exponent can be written as a coefficient, 2 times log of a plus log of b. Now, we might see what's going to happen here, because I know that log of a is 3, so 2 times 3, and I know that log of b is 2 plus 2. Can we do 6 plus 2, anybody? If you got to use your fingers to count, that's okay. I got 8. My answer is G. That's good. That's good. Well, thank you guys for sticking around here in this video. Make sure that you watch part 2 when it pops, and good luck on your ACT if you're taking it here soon, or maybe you're taking it for a second time. Got a ton of videos to help you guys prep for that ACT, so thanks for watching. If you have any questions or requests for videos, pop them in the comments. Otherwise, have a dope day.